Hello everyone, I'm Letitia and today I'm presenting algebraic properties to you guys. Okay, this is my table of contents. We have definition, comparison, relationship, circumstance, and testimony. So, first, definition. We'll be answering the question, what is algebraic properties? So, these are the properties. We have commutative, associative, identity, inverse, and distributive. And we have their formula, the example of their formula at the back of them. So, identity property. We can say that 0 is the additive identity and 1 is the multiplicative identity. Similarly, from the inverse property, negative a is the additive inverse of a, and 1 divided by a is the multiplicative inverse of a, because they each equal the associated identity. Now we're talking about distributive property. The distributive property is a property that allows you to multiply a number in the sum by distributing the multiplier outside the parenthesis with each addend inside the parenthesis. It shows how to multiply a polynomial by the factor. You can also factor out undistributing a common denominator of the polynomial. And we have inverse property. Inverse property is functions that can undo each other. And commutative property is changing the order of the operands does not change the results. And associative property is changing the grouping of the numbers does not change the result. Okay, we're jumping to comparison. Today, the comparison, we will be comparing what is the difference between commutative and associative property. So, now we see that commutative property comes from the word commute, which means move around, switch, or swap the numbers, while associative property comes from the word associate, which deals with the grouping of numbers. So, the order of numbers can be changed in the case of addition and multiplication of two numbers without changing the final result in commutative property. While in associative property, grouping of numbers can be changed in the case of addition and multiplication of three numbers without changing the final results. And these are the formulas. Now we're jumping to relationship. Let's solve some questions. While going along with the properties of algebra is the order of operations. So we look at the operations set of guidelines that allows mathematicians to perform problems in the exact same way. So we know it was called PEMDAS, which stands for parentheses, exponents, multiplication, division, addition, and subtraction. Now let's go. After reviewing our order of operations, let's solve some problems. Math exercise number 1. Find out x and recognize which property to use in this formula. 3 times open parenthesis 5x plus 6 close parenthesis equals 63. So first, we can turn this equation using distributive property. So 3 times 5x equals 15x, and 3 times 6x is 18x. So we know that 15x add 16 equals 63. Okay. Now we turn 15x equals 63 minus 18. And 15x equals 45. So we know that x equals 3. Good job. Next, turn the math exercise number 2. Jackie's mother asks him whether the addition of two natural numbers is an example of the commutative property. Can you help Jackie find out whether it is commutative or not? So, the solution of this question is, we know that a commutative property of addition states that changing the order of the addends does not change the value of the sum. If we take any two natural numbers, says 2 and 5, then 2 plus 5 equals 7 equals 5 plus 2. Therefore, the addition of two natural numbers is an example of the commutative property. So, the answer is yes, it is the example. Math exercise number 3. Josh buys 10 bundles of red yarn, 8 bundles of green, 6 bundles of blue, and another 6 bundles of yellow for 3 and 49 each. Multiply the sum of bundles of yarn by 3.59 to find the total cost of the yarn. First, write an expression to find the total cost of the yarn. So we know we multiply 3 and the 59th to 10 plus 8 plus 6 plus 6. So we got the answer of like this, 104th and 7th. Now we turn to circumstance. What is the background of algebra? And what makes algebra? These are the most common algebra topics. We have algebraic expression, sequence and series, exponents, logarithms, and sets. So first, let's dig deep into algebraic expressions. So, this is a type of all the algebraic expressions. We have variables, coefficient, constants, and the two terms. Or you can have many terms as you want. So, algebraic expressions are also known as polynomials. A polynomial is an expression consisting of variables, coefficients, and non-negative integer exponents of variables. An equation is a mathematical statement with an equal to symbol between two algebraic expressions that can have equal values. These are different types of equations based on the degree of the variable. So we have linear equation, which means linear equations help in representing the relationship between variables such as x, y, and z, and are expressed in exponents of 1 degree. While quadratic equations can be written in the standard form as ax to the power of 2 plus bx plus c equals 0, where a, b, c are constants and x is the variable. The value of x that satisfy the equation are called solutions of the equation, and the quadratic equation has at most 2 solutions. Now the third one is cubic equations. The algebraic equations with variables with power of 3 are called cubic equations. A generalized form of a cubic equation is ax to the power of 3 plus bx to the power of 2 plus cx plus d equals 0. Now, we can look at sequence and series. A sequence is a set of numbers having a common mathematical relationship between the number, and a series is the sum of the term of a sequence. In mathematics, we have two broad numbers, sequence and series. In the form of arithmetic progression and geometric progression, some of these series are finite and some series are infinite. So, arithmetic progression is a special type of progression in which the difference between two consecutive terms is always a constant, while geometric progressions is any progression in which the ratio of adjacent term is fixed as geometric progression. So, you can look at the example down there. Oh, sorry. Oh, okay. So now we have exponents, logarithms, and sets. So exponents is a mathematical operations written as a to the power of n. Here the expression a to the power of n involves two numbers, the base a and exponent or power n. The logarithm is the inverse function of exponents in algebra. The exponential form represented as a to the power of x equals n can be transformed into logarithmic form as a to the power of x equals n turns into log a n equals x. A set is a well-defined collection of distinct objects, and is used to represent algebraic variables. You can see the example below. These are the sets. Now, going to testimony. How is properties of algebra used in real life? Okay, let's see. We have recipes, interiors, landscape designing, business and finances, management, sports, finding the tax liability. We have cooking, sports, shopping, computer programming, interiors, business and finance, and health and fitness. There's so many ways we can use algebra in real life. Now, we're talking about linear algebra. Linear algebra have also multiple uses in real life. So, next part, we're talking about who invented algebra. So, this guy, Muhammad ibn Musa al-Khwarizmi, was a 9th century Muslim mathematician and astronomer. He is known as father of algebra, a word derived from the title of his book, Katib al-Yabar. Okay. And the word algebra originates from the Arabic algebra, which means the reunion of broken parts. Okay, that's it for today, and I hope you enjoyed this video. Don't forget to like and subscribe. Sorry. Bye.